And we're going to go to number 11. All right. Below is two polygons. We have polygon A, B, C, D, and then polygon A prime, B prime, C prime, D prime. All right. Obviously, this is the bigger polygon, and this one is the smaller one. You notice here that this top line connects the point A prime to A. Then this line connects B prime to B, C prime to C, and D prime to D. The point where these lines, these long lines here, all intersect with each other is called the center of dilation. Center of dilation. Okay. So we're moving on now. We're going to use that scale factor that we figured out earlier to find some missing angles here. So first things first, we're going to fill in the angles that it gives us. So it tells us that AD is 4. So we're going to put a 4 right there. It tells us that AB is 6. And it tells us that CD is 12. So we are able to fill in those. Then it tells us A prime, B prime is 9, and B prime, C prime is 21. It wants us to find the perimeter of A prime, B prime, C prime, D prime. So we're going to need to know 1, 2, these two missing sides. And then just for fun, when we're done finding those, we're going to go ahead and find this BC side as well. Okay? Alright, so first things first, we're going to need some scale factors. So, this is where the to and from really comes in handy. If we are going to the big triangle, or this one's a polygon, if we're going to the big polygon from the small polygon, that means we're going to have a big corresponding side on top and a small on bottom. So we have to figure out which corresponding sides both have numbers that we can use to find the scale factor. And if you look around and see which ones match up, the only side in both polygons that has numbers is that AB side. So we're going to look at the big, which is 9, and put that over the small, which is 6. You can simplify that, divide both of those by 3 to get 3 over 2 as our scale factor. That's when you're wanting to find the big sides. Later, when we find that small side, we're going to be going to small from big. So that's going to be small matches up with 6, so 6 is on top. Big matches up with 9. Simplify that, 2/3. So you guys can see that these two scale factors really just flip when they go back and forth. It starts off as 3 over 2, it becomes 2 over 3. Alright, next we're going to find, let's say we find side A prime, D prime first. So let's find A prime, D prime. So that since we want to find the big side, we're going to the big shape. We're going to use 2 big, this top scale factor. So we're going to do 3 over 2, and we're going to multiply that by the side that we need to find. So we need to find AD. That matches up with AD here. AD is 4. This multiplies out to be 12 over 2. 12 divided by 2 is 6. So our first missing side here, 6. Okay. Next one we want to find, D prime, C prime. Again, we're going too big, so we're going to use that same scale factor. Just going to be multiplying it by a different number. If we're finding d prime c prime, we're going to want to use dc, which is 12. Okay? This comes out to be 18. So we found 6, 18, 21, 9. And I said the last thing that we want to go ahead and find that missing side on the small triangle just for fun. Okay? So we're going to find that missing side on the small triangle is BC. This is on the small polygon. So we're going to small from big. We're using this scale factor. 2/3. We're missing the BC side, so the BC side on the big polygon is 21. This is going to come out to be 14. I'm going to fill 14 in right there. Okay? If you want to find the perimeter of A prime, B prime, C prime, D prime, what are you going to do? You're just going to add up 1, 2, 3, 4. That's how you find the perimeter. You add up all the sides. Okay, so that's it for that problem. Let me ask you a question though right now. If the measure says the measure of ADC, so that's in our original shape, measure of ADC is right here, this angle, and it says that it's 74 degrees. So it wants us to find the measure of A prime, D prime, C prime, which is right here. Okay, so you have to think back to what we said on that front side. What did we say about corresponding angles when we do dilation? They are always going to be congruent. So even though it started out at 74 degrees, that doesn't mean that it's going to change just because we dilate it. It's still going to be 74 degrees. Both of these angles are 74 degrees. Alright, last problem we're doing on dilation, and then we're done with this type of transformation. Okay? We're going to be talking about triangle XYZ and triangle X prime, Y prime, Z prime. So first, let's draw triangle X, Y, Z. And then we have triangle X prime, Y prime, Z prime. Alright. It tells us that XY, 6, ZY is 8. Then X prime, Z prime is 30, so that's down here. And Z prime, Y prime is 20. So it just wants us to find the missing sides. So our missing side on the small one is XZ. Our missing on the big is X prime, Y prime. So now we're going to find our scale factor, and we are going to find our missing sides. So let's say I want to go to the big triangle. I want to find the big triangle first. Go to big from small. Okay, we have to match up the sides. So it looks like 8 and 20 are going to match up. They both have Y and Z. Y and Z. So big has to be on top, 20. The small has to be on bottom, 8. Okay? I can divide both of those numbers by 4, it looks like. So I'm going to get 5, that is a 5, over 2. So that's my too big from small scale factor. So, from what we just learned up here, my too small from big is going to be 2 over 5. It just flips. Alright, so let's find this big side first. Too big from small. So X prime, Y prime is going to be 5 halves times corresponding side to x prime, y prime is going to be just regular xy times 6. It's going to be 15. Alright, then when we find our xz, we're going to use too small from big, because this is our small shape. Too small from big is 2 over 5. We're going to times it by 30. Okay? And that's going to give us 12 right here. Alright, awesome. We're going to finish it up by doing some angle stuff right here. We're going to finish it up by doing some angle stuff. Hold up, I'm going to move this up for a second. Alright. Alright. Down here at the bottom, it says that the measure of angle x, let me grab a different color, measure of angle x is 2x. The measure of angle y is 4x. And the measure of angle z is 3x. Then it tells us it wants us to find the measure of angle y prime. Again, what did we say about corresponding angles? They are going to be congruent. So if y prime is the same as y, and y is 4x, then y prime is also going to be 4x. So now, all we have to figure out what x is, and we can substitute that in and solve for that angle. So, if we know 3 angles of a triangle, we should be able to use our triangle rule to figure out what x is going to be. Triangles always add up to 180 degrees. So we are going to add up these angles and set them equal to 180 degrees. That's 2x plus 3x plus 4x equals 180. Combine like terms over here. 4, 5, 6, 7, 8, 9. 9x equals 180. Divide both sides by 9. And we get x equals 20. All we have to do is substitute that in up here. 4 times 20. And that's going to be 80 degrees. So that solves our problem. Okay. That's it for dilations, so make sure you put this in your notes section of your binder, and we'll get on to the rest of the notes for the day.